Welcome back, children. We can continue the problems of properties of determinants. By using properties of determinants, prove that. So this section is very important, one sure question for board exam. Maybe 6-mark question or definitely 4-mark question. So it's very important. Look at the question. Determinant minus a square ab ac ba minus b square bc ca cb minus c square is equal to 4a square b square c square. By using properties of determinant, we have to prove. So look at the question. You have to check all the 9 elements. Can we take anything outside? All the elements you have to check, row wise and column wise. So when we look the first row, a square ab ac, a is common. Second row, ba minus b square bc, b is common. ca cb minus c square in the third row, c is common, or column wise also you can do. So from the first row, here I am taking from the first row, a we can take outside. Okay. Then from the second row, b we can take outside, and from the third row, c we can take outside. So a, b, c is outside of the determinant, or column wise you can take, no problem. So what is left here is minus a. Then from AB, 1b, then AC, C. Then next row, B outside. So A minus B, then C. Okay. Now from the last row, C is outside. So A, B and minus C. Here I write, here what we did, taking out A from R1, then B from R2 and C from R3. Now again you check, A is common in the first column, B is in the second column, C is in the third column. So taking out A from first column, B from second column, C from third column. So we get A square, B square, C square. Then determinant minus 1, 1, 1, 1, 1, minus 1, 1, 1, minus 1. So here taking out A from C1 and B from C2, C from C3. Okay, and here for determinants we can use row and column simultaneously, but for elementary operation in chapter 3 matrices, if we use row, then we have to do all using row, otherwise column. We can't mix, but here we can do. Then now again we can simplify. Expansion is little bit difficult, so again we can simplify. A square, B square, C square minus 1, 1, 1. If I write R2 implies R2 plus R1, then that becomes 0. This also 0, then here we get 2. So if zeros are there, it is easy to expand. Same way R3. This 1 and minus 1, when we add, that becomes 0. So R3 implies R3 plus R1. So these are the operations we are doing here. So 0, addition 0, 1 plus 1 is 2. Then 1 and minus 1, 0, 1 plus 1 is 2, minus 1 plus 1 is 0. Now we simplify this into this form. Now we can expand. Here look, first column 2 elements are 0, only 1 element is there. So we can expand along C1. So here expanding along C1. So that is equal to a square b square c square into, put a bracket, minus 1 into, delete the row and column. So we get 2 by 2 determinant, this one. Then next two elements are zeros. Now find the value of the determinant. A square b square c square into minus 1 into 0 minus 4. So that becomes 4. So the answer is 4a square b square c square. So once again you check. We have to prove this using properties of determinants. So first you have to check all the 9 elements, and row wise or column wise you have to check, and anything is common you can take outside. First step is from row 1a, row 2b, row 3c we take outside. Then again from C1, C2, C3 we take a, b, c outside. So a square, b square, c square. Then we get a determinant. Again we simplify that determinant by adding R2 and R1, R3 and R1. So this way first column 2 elements are 0, only 1 element. So we expand along C1. So we get the answer. Now the second question. Second question, determinant 1, 1, 1, a, b, c, a cube, b cube, c cube is equal to a minus b into b minus c into c minus a into a plus b plus c. So, here nothing is common, we can't take outside. Okay. Now, check the answer part also. Here a minus b, first fact. Can we get a minus b from this? A is in the first column, b is in the second column. If we subtract, that is C1 implies C1 minus C2, we get a minus b. And 1 minus 1 becomes 0, a cube minus b cube. Factorization we studied, a cube minus b cube. What are the factors of a cube minus b cube? A cube minus b cube is a minus b into a square plus ab plus b square. So there also you will get a minus b. Now again another next factor is b minus c. Can we get b minus c? Second column implies second column minus third column. So you will get b minus c. B cube minus c cube, there also b minus c is a factor. So first we are doing that. So how to write? C1, here column, C1 implies C1 minus C2 and C2 implies, together we can do C2 minus C3. Okay. Then when we do like this operations, only for 2 columns or 2 rows you can do. Don't do for all the 3 rows or all the 3 columns. So first one is 1 minus 1 0, then a minus b, a cube minus b cube. Then again 0, b minus c, b cube minus c cube, 1 c, c cube. Now factorize. 0, a minus b. The factors of a cube minus b cube, a minus b into a square plus ab plus b square. Now the second column 0, b minus c into b square plus bc plus c square, and last column as itself. Now look the first column and second column. In the first column a minus b, a minus b. 0 means we can write as 0 into a minus b. So a minus b is common in the first column, and similarly b minus c is common in the second column. So a minus b taking out b minus c also. Then we have 0, 1, a square plus ab plus b square, and 0, 1, b square plus bc plus c square, and 1c c cube. So here what we did, taking out a minus b from c1 and b minus c from c2. Now again we can simplify. Here two elements are 0, okay, only one element in the first row. We can expand, but when we expand 1 into, we get this 2 by 2 determinant. So it's when we multiply it's little bit difficult. So one more step we can do, that is a minus b into b minus c into, what we do is, when we subtract these 1 and 1, that becomes 0. Here we can again factorize. So our C1 implies C1 minus C2. So 0 minus 0 becomes 0, 1 minus 1 is 0. Then a square plus ab plus b square minus b square plus bc plus c square. Then 0, 1, and 1c c cube. So a minus b into b minus c into, here b square cancel. A square minus c square, then ab minus bc. Here 0, 1, b square plus bc plus c square, 1c c cube. Again look at the first column. Can we factorize that? Here two elements are 0. A minus c. A square minus c square factors. A minus c into a plus c. Plus ab minus bc. When we take b outside, there is a minus c. Then 0, 1, b square plus bc plus c square, 1c c cube. B minus c. Now from the first column, a minus b we can take outside. In these two terms a minus c is common. So a minus c out, take out, 0, 0. When we take a minus c outside, we get a plus b plus c. Then 0, 1, b square plus bc plus c square. Then 1c c cube. So here taking out a minus c from C1. Now we can expand. A minus b, b minus c, a minus c. Now we expand along R1. So 1 into, that 1 into determinant, delete the row and column, 0, 1. 0, 1, here a plus b plus c. Second element is like this. Now find the value of that. So 0 into this part is 0, then minus b minus c into a minus c into 0 into that is 0, minus of a plus b plus c. But in the question, the answer is given positive only, a plus b plus c. So if we change any factor, if we write in the reverse order, there we get one minus sign. That minus and this minus becomes positive. So answer is given like this: a minus b into b minus c. Here when we write c minus a, one negative is there. That negative into this negative becomes positive. So c minus a into a plus b plus c. So that is the result. Okay, once again you go through this. It's lengthy one. Okay, step by step you check. First step is we look the answer part. Then you have to start. A minus b and b minus c, how we get? So a minus b is c1 implies c1 minus c2. And C2 implies C2 minus C3. When we do these operations, we get A minus B and B minus C. And A minus B is common in the first column, B minus C is common in the second column. So we take that two factors outside. Then 0, 1, this A square plus AB plus B square, 0, 1, B square plus BC plus C square, 1C, C cube. Then you can expand, no problem, at least two operations you have to do. Then you can expand, but little bit difficult, that's why I did next step. That next step is subtraction. C1 implies C1 minus C2. So b square cancel, then a square minus c square and ab minus bc. This again we can factorize, a plus c into a minus c, b take outside, so there is also 1a minus c. Then from c1 a minus c outside, then after that expanding. So here negative sign, so here you have to write in reverse order. So check the answer is correct. A minus b into b minus c into c minus a into a plus b plus c. So the final. Okay, the next question. Determinant x square yz, y square zx, z square xy is equal to x minus y minus z minus x, xy plus yz plus zx. Just like the previous question, how we get here also we can't take anything outside. So you have to check the answer part. We have x minus y minus z. So you check how we do x minus y. How we get x minus y, x is here, y is here when we subtract. Here x square minus y square, there also x minus y, yz minus zx, when we take z outside there also you get. So we do operations. R1 implies R1 minus R2 and R2 implies R2 minus R3. Only two operation you can do. You don't do R3 also like this. Okay, at a time two operations like this you can do. Y minus z, x square minus y square, z square. Here R1 means R1 minus R2, z is common, y minus x. Then R2 minus R3, x is common, z minus y. Okay. Now what is common in the first row? First row x minus y into x plus y. Here x minus y common means you have to write minus of z, minus you have to take outside. So that's equal to taking x minus y from the first row and y minus z from the second row. So 1 1 z. Here x plus y is there. Then y plus z and z square. Here minus z minus x, then xy. here taking out x minus y from R1, y minus z from R2. Now, if two ones like this, convert one to 0 using the other one. That is, we can do R2 implies R2 minus R1, or you can do R1 implies R1 minus R2. In the question, it is z minus x. So, z minus x means you have to do R2 minus R1. So, x minus y into y minus z into 1 x plus y minus z 0, subtract y cancel, z minus x, then again z minus x, z square xy. Okay. So, z minus x is common in the second row, taking out that y minus z into z minus x, then determinant 1 0 z, x plus y minus z 1 1 z square xy. Taking out z minus x from R2. Now you can expand, no other simplification possible there. Okay, expanding along, which way you can expand? C1 is easy. In R1 3 elements are there, here one element is 0. So, expanding along C1. So, 1 into, okay, 1 into determinant, delete the row and column. So, we get 1 1 z square xy. Then next element 0, then last element 0, then last element z, delete the row and column. So, x plus y minus z 1 1. Now, expand that. X minus y into y minus z into z minus x into, what is the value of this? Sorry. It is xy minus z square, then 0, then plus z into, cross multiply, x plus y plus z. Now you have to multiply that. X minus y into y minus z into z minus x into square bracket xy minus z square plus xz plus yz plus z square. Z square cancel. So, the final answer x minus y into y minus z into z minus x into, so you can write in order xy plus yz plus zx. So, that is given as RHS. Check the answer. The answer is x minus y, y minus z, z minus x into xy plus yz plus zx. So, in the first step, we subtract R1 implies R1 minus R2 and R2 implies R2 minus R3. Then from the first row, we take x minus y outside. From the second row, y minus z outside. Then again we convert 1 to 0 by subtracting R2 implies R2 minus R1. So, we get z minus x, that we take outside, then we expand. Expanding along C1, then open the bracket, then we get the final answer. Okay. Then the last question. Prove that determinant 1x x square 1x x square 1 is equal to 1 minus x cube whole square. So here we can't take anything outside. Also when we subtract this answer part, again we can factorize, but it is not like this, we won't get. So what we do is you add everything to that row wise. Row wise means or column wise. That is R1 implies you can do R1 plus R2 plus R3. Or C1 implies C1 plus C2 plus C3. If you add, first when we get a question, you add like this. Add like this and check whether there is common factor in the first row. Or column wise you add and check whether common factor in the first column. If there is common factor, you can take outside, then you can do the remaining steps. So here look, when we add, if we add row wise, okay, row wise means 1 x square x, you have to add 1 plus x square. Now add these three terms, again you get 1 plus x square, third element also, doing this operation, okay. So I'll write the question once again. 1 x square 1 x square 1. This R1 implies R1 plus R2 plus R3. Now the second element x square 1 x square 1. So 1 plus x square is common in the first row. We can take that outside. Then determinant 1 x square 1 x square 1. Okay. If all the three elements are 1, you can convert 2 1s to 0. 1 you have to keep as itself. So here we can do the operations 1 plus x square into C2 implies, okay, C2 implies C2 minus C1, and again C3 implies C3 minus C1. So C1 as itself, C2 and C3 you have to change, or C2 you have to keep as itself, the other two you have to change, that way. So 1 minus x square minus x, 0, x minus x square, 1 minus x. Now anything common in the second column and third column? 1 x square x, 0. We can factorize 1 minus x square as 1 minus x into 1 plus x. Okay. Then when we take x outside, x minus 1 we get, here 0, x into 1 minus x, here 1 minus x. Okay. So we can take, look, 1 minus x from this column. Second column we can take outside, 1 minus x from the third column also we can take outside. So 1 plus x square into 1 minus x from second column, again 1 minus x from third column. 0, 1 plus x. When we take 1 minus x outside, this x becomes minus x, 0, x, 1. Taking out 1 minus x from C2 and C3. Now you can expand. Look at the first row, two elements are 0 and the one element is 1. So 1 plus x square, this we can combine and we can write whole square, then into 1 into delete the row and column. So we have determinant like this, that's equal to 1 plus x square into 1 minus x whole square into cross multiply 1 plus x square. So we have 1 plus x square whole square and 1 minus x whole square. That we can combine and write 1 minus x into 1 plus x square. Square for both. So we can put a bracket and write square. And this is of the form a minus b into a square plus ab plus b square. That is a cube minus b cube. So its square. So that's equal to 1 minus x cube square. That is given in the question. Right hand side RHS. Check the answer. Look at the question. 1 minus x cube raised to whole square. So once again, first we add. R1 implies R1 plus R2 plus R3. You can do C1 also. C1 implies C1 plus C2 plus C3. Same way you can do. Then we take that factor outside. 1 1 1 x square 1 x square 1. Then we subtract. If 3 1s are there, 2 1 you can convert to 0. 1 1 you have to keep as itself. So C2 and C3 we change. Then from C2 and C3 we take 1 minus x outside. Then we expand. So 1 minus x whole square we get and 1 plus x square, and when we expand we get one more 1 plus x square. Then we combined. So this is of the form a cube minus b cube. So we get 1 minus x cube whole square, that's equal to RHS. I hope all of you understood this. Thank you.